This is the Q-Tran Voltage Drop demonstration kit, and this kit is designed really to show what separates our transformers or power supplies from the standard transformer that you would get from either an electrical supply house or a lighting manufacturer on a low voltage lighting system. Our transformers are toroidal, which are round in design, and toroids are known for being a quiet transformer, so we help address some noise issues. But more importantly, with any low voltage lamp, on this demonstration we're using the MR16 lamp, but it could be any low voltage lamp. If they lose a little bit of voltage, they're made to operate at 12 volts or 24 volts. If they lose just a small amount of voltage, as little as 0.6 of a volt, you actually lose about 15% of your light output at 11.4 volts. If you operate them closer to 10 volts, you actually lose about 50% of your light output. And as you can see, or you will see in this demonstration, you can do that being a remote mounted as little as 20 feet away. So on the demonstration kit we have 4 meters here on the left hand side that show the voltage coming in. Right now it reads about 120.2. That voltage can vary, so we have ways of compensating for that voltage as well if it happens to be high or low on the primary side. We show it right after a dimmer. We have a Q-Tran dimmer here, a magnetic low voltage dimmer. And you'll notice that whenever you run through a dimmer or a dimming module of any sort, you have what's called dimming loss because it's not 100% efficient as an electrical device. So our voltage actually drops from 120 here to about 113 here. Typically it's about 5% of your primary voltage is lost, which means in turn that the transformer no longer sees 120 volts as its primary. It's now seeing 113 or 112 volts as its primary, reducing the secondary output on the transformer. So our transformer in here is putting out 10.8 volts right now instead of 12. We go through 25 feet of 10 gauge wire to a 300 watt load. We happen to have 6 50 watt MR16s on this load, but a 300 watt load is the top end of a load that you can run off of a low voltage transformer. It's 25 amps at 12 volts. So out at our load where we really need that 12 volts, we're down to about 9.5 volts, you'll see here on the bottom meter. What that means is we're getting less than 50% of the light output that we should be getting out of these lamps and still burning the full power to get that. We're just losing that voltage as it travels down that wire to the load. In addition to that, this demonstration kit shows the audible difference between our transformers and other transformers. So in here we have a standard stack laminated or EI transformer that most other manufacturers use, and then we have one of our toroidals. So I don't know if you'll be able to pick up the sound difference, but most transformers make an audible noise, especially when you dim them. As you dim, you begin to turn the lights on and off through the triac inside the dimmer, and that puts the transformer under stress and will cause it to make a buzzing or a humming noise. So with Q-Tran, the first thing that you'll typically notice, and what we're really known for, is having a silent transformer. So when you have that audible noise, when you go to Q-Tran, you have absolutely no noise. We give you a no noise guarantee, so that's the first issue. What that means is no complaints from a customer, number one, but also that you can put the transformer very close to the load and reduce your secondary runs, reduce that voltage drop overall. So when I go to Q-Tran, we have voltage drop the same as anybody else would at certain voltages. So in here, what we do is we use multiple taps. So up here you'll see tap 2 through tap 5. Our typical transformer will have 5 output taps. That allows an installing contractor to determine, based on how far away he is and what the load is that he has on that transformer, he can literally pick the tap he needs to deliver the 12 volts, not from the transformer, but at the load itself, because it's really the lamp itself that needs to see 12 volts. So on our 12 volt tap, which is tap 2 here, you will notice that we're putting out about the same voltage. We're about 113 after the dimmer. We're 10.7 coming out of the transformer. We're about 9.5 out at the load. But with our multiple taps, when a contractor gets a reading like that, he merely bumps up the voltage 1 volt at a time till he gets to the right voltage out here at the load. So once we tap up there, we jump up to about 10.5. On tap 4, we'll jump up to almost 11. Tap 5, we jump up to about 11.5. The ideal voltage, we believe, is between 11.4 and 12. You can never be exactly at 12, but the closer you get, the better light output that you have. You also notice not only the intensity of the light, but the quality of the light. An MR16, when it burns at full voltage, is a very bright, crisp, white light. And as you reduce voltage to that, you will notice that it turns sort of an orangish or amber color. So when I go at full bright with our transformer, we're getting a foot candle meter reading here of about 620 foot candles from those 650 watt MR16s above us. When I flip to the other transformer, you'll notice that the light output drops. Our foot candle meter reading now is about 335 foot candles because of this 10 volts or 9.5 volts at the lamp. When I go back to Q-Tran, you'll notice that it jumps back up. So what that means, we give you a better quality light. We also deliver that light over the distance and still maintain voltage. But you're getting roughly about twice the amount of light output using our transformer versus another transformer, which means that if it's enough light at the lower level, you could easily reduce the wattage of your lamps and go from 50 watt lamps down to 32 or 35 watt lamps. Or you can have them at full bright and still have the ability to dim them. Another critical issue with these lamps is they're halogen lamps. And if you read the instruction sheets on the typical cut sheet from a manufacturer, they say that the lamp needs to operate at 12 volts. The halogen cycle begins at about 250 degrees C on the inside of the lamp envelope. By reducing the voltage or running the lamps at 10 volts because of voltage drop, you have the potential of shortening that lamp life because the halogen cycle can't maintain itself and reattach the tungsten from the filament that's come off the filament. It doesn't reattach if it doesn't reach that temperature. So once again, we can give you full light output. You have the ability to dim that, and as you dim those lights, you have great lamp life extensions. Dimming just 10%, which is about right there, doubles your lamp life. So you can take a 5,000 hour lamp, make it a 10,000 hour lamp. Dimming 20% quadruples your lamp life. So you take that 5,000 hour lamp, it's now a 20,000 hour lamp, thus reducing energy as well as reducing your maintenance costs. Periodically, if the lamps begin to darken, per the cut sheets from the manufacturers, you merely bring it up to full voltage for 15 minutes. The lamps will self-correct and clean themselves. So with Q-Tran, it's all about the quality of the transformer, delivering full light output, reducing your overall wattage consumption, giving you a product that makes no audible noise with the ability to dim it, and then lastly, giving you something that's going to last 10 to 25 years in the field.